Okay, so the next one, the interesting topic, deep learning. Entire world is hanging on this deep learning now, right? So, uh, I hope you got clear understanding of machine learning, right? Now let's see deep learning. And again, please keep this in mind only for unstructured data, right? So classic ML needs the structured data, right? Could be text or numbers and categorical or numerical. But wherein deep learning learns for unstructured data. Why? What is the use? So far, we went through this data engineering, data science, ML, and right now we are in deep learning. Okay, so when let's start with a simple question. I'm sorry, once. So yeah, why deep learning? So if machine learning is already working, right? So why did the world, need deep learning? So imagine our example, right? This Shopsphere. So it has like 12 million product images, right? So across all the categories, like maybe like shoes, jackets, right? And laptops, phones, etc. So furniture. So now suppose we want a computer to identify whether an image is a shoe or not, or an image contains a shoe, right? So traditional machine learning would ask us to define the features, right? That's what we learned, right? In the example also. So you have your x1, x2, and so on, x100, all these features. So you train machine these features. So you try to build a relationship. Now, in this case, if you have an image and we want to check whether this image contains a shoe or not, right? It will ask like, what is the length, what is the color, width, edge count, shape, etc. So the engineer must decide, which is important. But think about the scale. Even if you able to define the rules, can we manually define rules for 12 million product photos, I'm sorry, impossible, right? Okay, even if you could, even shoe looks different, different colors, different angles, different lighting, different backgrounds. The rules quickly break. You can set a rule for one shoe, but what about different colors, different angles? A shoe may be, striped shoe like this, or maybe in this direction. So different directions, right? So the rules quickly break. So this is where deep learning changed everything. Instead of human telling the computer what features matter, the computer learn those features automatically. Okay, so it starts with the pixel, the raw pixel. Suppose if I'm talking about image only right now, so we're not discussing about text. So if there is an image, it starts with the raw pixels. Then it learns the edges of those images. Then what is the shape of those images, right? So then the patterns, then the objects. So here I have mentioned clearly the pixels, edges, textures, parts, and objects. Eventually, it discovers, okay, this is a image of a shoe. So without anyone explicitly teaching it what a shoe looks like, that's the breakthrough in image processing or maybe in deep learning. So deep learning learns the representations automatically based on the flow that we just discussed. Start from the pixel and then edge and the shape or texture, different parts, right? So that's the reason this is very, very important and it dominates. You have image recognition, you have speech recognition, you have language understanding, recommendation systems, and of course, very importantly, these days, Gen AI. Everything comes under deep learning. Okay, so the word deep means not, deeper intelligent. It simply means many layers stacked together. So if you come back and see the way how I put it here is pixels, edges, texture. So many layers stacked together. So machine will understand each and every layer and try to extract and classify the respective image. That's actually deep learning. Okay, so I just briefed about deep learning, right? So this deep learning is built on this neural network framework. So what is this neuron and what is this neural network? Before we get in there, right, let me give a simple example. Suppose you have decided to buy a house, right? So you're deciding, or you have decided to buy a house. What you will do, you explore the location or different localities, right? So then your, of course, this is important, the price or budget, then the distance, the commute time or distance between your office, your work location, and the respective house location. Then also, if you have children, you also check on the schools, right? And more like how far it is from the highways and so on. So you give all these inputs. You consider all these inputs as a feature. Let's say the machine learning language is a feature. These inputs you pass through your brain. Your brain combines all these factors before making a decision, right? Hope you understand, right? Anything, not only this example. If you see something, your brain reads it and it processes it, and then you give an output. All right. So an artificial neuron, okay, this one, the neuron works similarly. It receives multiple inputs. Each input has a level of importance. That's called as a weight. Okay. So it receives multiple inputs. A neuron receives multiple inputs. Each input has an importance. In mathematics, we call it as weight, right? The neuron combines everything together and produces an output. That's it. This is simple. In between, you have activation function, etc. I'll discuss with example. Don't worry. When we, of course, deep learning, I'll be going through one worked out example, so you will understand in detail what exactly the activation function and all. Right. So that is about a simple neuron. What happens when we connect thousands or millions of neurons together? That's a neural network. That's it. Right? So think of like a company, right? At the bottom, all employees collecting information. In the middle, managers are processing information. At the top, leadership is making decisions. So you have so many employees you have here. They're working on something or they're processing some information. The mid-level, there are managers here. Then finally, the company head, the leadership is making decisions. So this is your output, right? So two examples I have given, layman examples, and we will do one example on ShopSpear, e-commerce example, the way how we did on ML, right? So here you have input layer, where this layer receives the data, right? If it is an image processing example, pixel values, right? Then the hidden value, sorry, hidden layer, where it actually learns the pattern, right? Then the output layer is makes the prediction, right? So input layer, hidden layer, and output layer. So and during the training, billions of weights are continuously adjusted until the network starts making accurate decisions. So you start with zero weight, zero bias, and you start increasing this each 0.01, 0.02, and so on up to a certain level where the model reach an accurate stage, or maybe the accuracy is good, right? So these whatever rules that we just discussed, right? So it is not possible to program manually. Human, nobody can program this. So that's the reason network learns from its previous layer. Every stage it learns from its previous layer, previous stage, and update the weights, process to the next layer, then and so on, and finally you get your output. Okay, so that is neural network. Simple analogy here is, so there are, imagine you have 100 features. If it is not an image, it's a raw data, it's a structured data. So your ML fails to predict the build the relationship. Imagine, just for the sake of example. So these 100 features get into your input. Then you start updating the weights to each and every feature. Then it calculate your y hat. If it is not accurate, y minus y hat, the accuracy is not good enough, then it will repeat again, updating the weights, again updating the weights. So this is neural networks, neural network. Okay. So we have image processing, we have text processing, and we have structured data. I mean, we do have deep learning algorithms for structured data as well. So let's discuss more. So I briefed neural networks, how the neural network, the architecture or framework works actually. The simple examples. Now, I hope you understand at a high level, right? So using neural network, primarily we have three broad use cases, or I could say three broad, areas where we can solve problems. So one is for image, right? The other one is for text, and the third one is for structured data, so tabular data also. Let's talk about image. This is very, very important. So CNN, convolutional neural networks. Convolutional neural networks, basically, this is one type of architecture. So this is used to extract the image and classify as per the training. Okay, so you are given this to the computer, the ability to see the way how we see, basically. The moment you see a particular object, first you see the color, shape, etc., etc. Then you can conclude saying that this is the relevant object name, etc. Right? So imagine showing a photograph to a computer, simple, the way how humans we see, wherein we see based on our, since childhood we got trained on that, you can recognize and replicate. But wherein, unlike humans, computers don't immediately understand. So what you have to do, whether it is a dog or shoe or a person, for computers, what we have to do, we have to train them, saying that, okay, these are the images of, let's say, 1,000 images of dogs. So you just say classify this dog. So machine will read the respective image and feed this as a dog. When you show a next image, it will predict whether it is a dog or not. It's a simple classification. How it will happen? Few minutes back also we discussed. So it learns like edges, corners, pixels, curves, right? Everything, whatever you have, right? Simple example, autonomous car. So the moment it sees the image, it's a road or crosswalk or it's a red signal, based on that, it will handle and it will send the information back to the sensors. So based on the sensors information, the pedals, acceleration, brake, etc., they work, right? So similar way here, they understand different edges, different corners, different curves, shapes, etc., to recognize a particular pattern. So then it combines all the patterns, then it will say, okay, this is let's say a particular handle, or suppose if we're talking about a four-wheeler, right? So it's a two-wheeler, for example. So it decides based on the way how you classify. So now think about how a child learns, right? So child first recognize eyes, then face, then people, correct? So the moment you see anyone, right? So you see the eyes, then face, then the entire personality. So then you can say, oh, he's so and so, she is so and so. Similarly, CNN also learn the same way, right? So facial recognition or medical imaging is a good example. Self-driving cars is one example. Quality inspection system. Once you complete the product, through an image, it will say whether it is in quality or not. Okay, different layers involved in it. We will be running one example on CNN as well. So I'll explain, when I put the code, right? So there's a convolutional layer wherein it scans the image with small filters, identify the edges, corners, and everything. Then automatically learns during the training. Okay, suppose if this is the image, this is the shape, this is the corner, then this is a dog. This is how you actually train the machine. So this is the convolutional layer. Where in pooling layer, it reduces the size of features. So instead of, let's say 256 by 256 or 1024 by 1024 pixel, it reduces, it pools, it understand each and every pixel. Then, extract the respective dimension and map to the respective image. All right. So that is pooling layer. Then fully connected means, so take all learned features and combine them to make the final prediction. Okay, so convolutional layer, then pooling layers, then fully connected layer. So this is how image gets processed through a CNN architecture to conclude whether it is a dog or a cat, right? So We'll do one image classification exercise, then you will understand more. But at a high level, to conclude on this slide, convolutional neural network is a type of architecture and deep learning which helps you to understand the images and help you to predict the respective class, whether it is a dog or cat or it's a whatever you put something like uh, car, autonomous car example, right? Or medical imaging, X-rays and all these days, the X-rays and imagings, whatever imaging outputs you get, right, in medical. So those are actually scanning through the CNNs and classifying whether a particular disease exists or not, right? The quality inspection system is another best example. So that's about CNNs, convolutional neural network. So in this slide, we'll discuss how networks learn. So I'll be giving intuition behind how networks learn and make a prediction, accurate prediction. Okay. So I'll give a simple example, very simple example. Imagine you are teaching something to a child, right? So you show an image which has dog and you say that this is dog. You show 10 different dog images. Then after that, you show an image and ask child, what is this image? Child may say that, this is cat. You correct it. No, this is not cat, this is dog. So you correct it. When child says something wrong answer, you correct it. Similarly, second image, you show something else, and child says that this is rabbit. Then again, you correct it. So after hundreds of examples, finally, child will say the correct answer. It's dog. Right? So what is happening here? So you trained child saying, showing some image. Child learns. Then you tested it. Just please be focused, here. You tested. So the child, response was wrong. Then you corrected it. Then again, you asked another question or showed another image. Again, the child was wrong. So you corrected it. Finally, you showed hundreds of examples. You corrected, finally reached the correct answer. So now apply the same logic. So first, the neural network, make a prediction. In simple language, so there is a y and x, so it makes a prediction y hat. So what you will do, this is the forward pass. So pass, calculate the loss. Loss is nothing but error. In layman language, it's error. This is nothing but the difference between the actual and predicted value. Simple, right? So this is the loss calculation. So you measure how wrong the prediction was, right? Then what you do, how we just discussed in this example, you make the child correct. So here what you do, you update some weights, do some internal settings, then send back. It's called back propagation. Okay. So the first step is take the inputs, apply weights, calculate your prediction, forward pass. So calculate loss. Then see if once you see that this is not an accurate prediction, you again adjust weights, then send it back, backward propagation. Then what it will do? It apply some method, right? So repeat millions of times. Eventually, prediction becomes accurate, right? So gradient descent is one of the method in layman language, function that helps you to optimize your weights and bias. So I'll discuss more when we run a worked out example, right? In Python, when I put the code, I'll explain each and everything, mathematics, basic mathematics, which is required for you to understand deep learning also. Okay, so this is how neural networks learn. Right? If I give one more example, very simple example, and this is my favorite, right? The radio knob example. So imagine thousands of knobs actually controlling the sound quality. So initially everything sounds terrible. So then you do adjust back propagation. So slightly up, left, right? So you turn the knobs up and right, up and down, or left and right. You try more times, like hundreds of times you do that. Eventually, you get the best music. This is exactly what neural networks are doing. Okay, so you make a prediction, calculate the loss, see if the loss is okay, acceptable, the prediction is accurate. If not, update your settings, adjust your weights, and do back propagation, send it back, then again calculate, then the prediction y hat, then do the loss. So repeat millions of times until you get a best accurate model. So that is why deep learning is so powerful. Neural networks is so powerful. So this is how the networks learns. So I'll give a use case, simple use case. This is not worked out example. This is, I mean, hands-on example. This is just to, for you to apply the learning what we did from the previous slide, right? So come back to our example, ShopSpear. Imagine the ShopSpear allows thousands of sellers, right? So the sellers basically could be sellers or manufacturers. What they do if they want to put a product in shopspear.com, just like our Amazon, right? They have to upload the products every day, right? So product images. So now imagine reviewing every image manually will take so much of time, right? So there are, let's say, 100K new products arriving every day, product images maybe. For one product, at least there will be 10 to 15 images will be there. So human review is definitely, it's not possible. It takes a lot of time. So then CNN, convolutional neural network, automatically check the image, and what it will do, it can help identify the product category. Which product is this, right? And if there is any damaged or defective items in the photo, they can actually identify it. And suppose if the photo is low resolution, if the image is not clear, blurry and all, right? Then it will identify, then it won't allow sellers to upload the product images, right? If there is any policy violation, prohibited item, for example, some items are prohibited, right? So those sort of things can be easily validated or checked during the placement when they want to place their products on shopspear.com. Okay, what is the business impact? So you are reducing the time from one product, it will take like 72 hours, wherein you can reduce it to 8 seconds per image. This is an example of another e-commerce, just I'm sharing for your understanding. Okay, and accuracy is 94% when you compare with human accuracy. Sometimes human we do mistake, wherein machine you trained well, so it classify as per the training, right? So seller satisfaction also gets improved, customer satisfaction also gets improved. Either both the ways it works. So you're generating value to the business. Okay, so this is a simple and very powerful, important use case wherein CNN help our ShopSpear to process the images while the sellers upload the product, the respective product catalog or images, right? Then, so this is about CNN. So I mentioned, right? So primarily, deep learning, we use the architecture to solve. One is images, the second is the text, and third is structured data. So the structured data, primarily, the sequential data. So sequential data, again, it could be number or text. What do you mean by sequential data? So if you have heard about this time series, right? It's the best example. First, we'll discuss about the time series. Then I'll give another example, the recommendation example that we discussed, right? So suppose today is what, let's say Jan 1st and so on up to June 30th of 1 year 2026. So what is the sequence data means? Current date, today's value. Imagine if you're talking about dollar sale, right? So today's value is either, I mean, is dependent on either previous day or last 2 days or last 3 days or last week's data. So that is actually sequence data, right? If I make it more simple for you, so take a simple text example. Text example. If suppose there is a question, right? There is a question, hey, how are you? I say that I am doing good. So now tell me this good is definitely depending on the previous word doing. Similarly here, right? So if you ever notice when you are replying in Gmail, right? It starts preempting the text, predicting the text, and it will display the text on a different font or a lighter font. Immediately, if you press enter or tab, it will, fill that particular word while you are compiling the message in your email. If you not noticed, please do check. That is the best feature, that best example of RNN. So built for sequences. Images are one type of data. Language is completely different. Language has an order. Similarly, time series data is also have order. So I'll be teaching you, or sorry, I will be showing you two examples, one on text data, one on time series data, how this RNNs and recurrent neural network and long short-term memories, LSTMs, RNN and LSTM works. Okay. So to make it more simple thing, right? Let's say if I give a text saying, hey, I love this move, and I don't love this move. So if I compare these two contain almost the same words, but very different meanings. What matters here? The order, the order of the words, the order of the numbers, or order of the words. So RNN, recurrent neural network, are were designed to handle this sort of sequences. Okay, so think of reading a sentence. Each new word depends on previous words. So RNN try to remember what happened earlier, right? So problem is that basically sometimes memory fades, right? Just like humans forget details about a long conversation. But long short-term memory, LSTM. So this is an improved version of RNN. So they introduced some mechanism that help model to remember important information for longer. Okay, so for many years, this LSTM is dominated, especially in the recommendations, speech recognition, translation, text analysis, etc. Okay, so I hope this example is clear. These two simple examples. Again, I'll give one more thing. Numeric, the structured data, right? For example, stock market prediction. So stock market, people do like, okay, tomorrow there is a chance of so and so number index. Let's say today the index is 25K, tomorrow it may go up to 25,200. So how this is happening? I mean, people might have used time series. You can actually use time series forecasting as well, but this recurrent neural network is more powerful than time series, right? So because today's value is mostly depend on last 2 days or 3 days values than last 1 month's value, right? So long short-term memory. That is the logic. So it tried to memorize what happened in long and also the short terms. Then try to predict or forecast for the next time period. Okay, so this is the next algorithm, this RNNs and LSTM. As I promised, you will be, once I complete the transformer part, I will be talking about the deep learning examples, right? You will learn how CNN works, RNNs and LSTM. Okay. Okay, so let's move here. The transformer, the breakthrough, right? This is where actually the transformer architecture is where is right now on for Gen AI, agentic AI. One of the most important slides I could say in the entire course, right? Because most of us we know Chat GPT. So what is T here? This is transformer, right? So ChatGPT, this exists, ChatGPT exists because of this invention, transformer. Okay, so before transformers, like model processed text sequentially, right? Just a minute back we discussed, right? LSTM or RNN. So models used to process the data text sequentially, one word at a time, like reading a book line by line. Transformers introduced a revolutionary idea. Okay, attention. Let's take a simple sentence, right? Maybe I'll give you one example. The trophy doesn't fit. Trophy. Trophy doesn't fit in the bag or maybe suitcase as it is too long. Simple statement. A trophy doesn't fit in the suitcase or bag because it is too large. What does it refer here? It is too large. It means what? Suitcase or trophy? The trophy, right? The trophy doesn't fit in the suitcase because it is, I'll write it again, sorry. Sorry for my handwriting, it is a bit. So the trophy does not fit in the suitcase because it is too large. So it is not actually the suitcase, it is the trophy. Okay. So as a human, we understand this naturally. Transformers do the same thing by looking at the relationship between all of the words simultaneously. That is the Transformers architecture. Earlier in the sequential thing, I love the movie, I don't love the movie. So based on the previous word, it will classify whether it is a sentiment, positive or negative. It will understand. So text word to word. But here, the entire sentence, it actually reads, and based on the sequence and also the relationship, it will try to understand and decide what does actually it means. Okay. So, um, and also maybe like you do one thing, a simple example. The same example, if you instead of reading left to right, so what if you read right to left, right? So just try to read. It is too large. It suitcase. So the relationship, the meaning, the context, everything gets changed. This is actually called attention. Okay, the words are most relevant to each other, right? So self attention. So machine will give attention to these things. So instead of listening to one or reading one at a time, so listen or read multiple things. Suppose if you are listening to one person, right? You don't listen, you can't listen 10 persons in one go. You listen one person at one time. Similarly, transformers, right? So transformers came, the same due to the sequential issue, they became more powerful. GPT, Claude, Gemini, Llama, all these, tools or I would say applications are built on transformer architecture. Okay. Now, embeddings. So what is this embeddings? So this is the embedding is basically, so yeah. Okay. And again, this is incredibly important, guys. Embedding, this is very, very important because modern AI does not truly understand words. If I say the movie is good or nice, so do you think machine will understand what is the meaning of good and all? No. But machine can translate this good into some numerical format so that machine will understand and try to get the meaning again in the numerical format so that it can apply any application like sentiments, extraction, classification, whatever, right? So it only understand numbers. So embeddings are how words become numbers. Imagine a giant map, right? Words with similar meaning live close together. For example, if you have you ever noticed your cloud maps or data maps, right? So whichever word is closer to the word, so they live close together, right? King and queen, doctor and nurse, car and vehicle, right? So they're near each other, so they come close together. Why? Because they appear in similar contexts. Okay, they appear in similar contexts. Now think about Shakespeare. Products can also become embeddings. Customers can become embeddings. Documents can become embeddings. Everything becomes a point in a giant mathematical space. So this enables the mathematical models so that we can leverage these powerful capabilities, especially recommendations, RAG systems, sentiment, maybe semantic similarity. You will understand all these things, when I discuss more, don't worry. But at a high level, try to understand what is embedding is. Embedding is a form of translating the text to number, all right? So why this matters downstream? Because if you search something, right, semantically, you search some similar documents. So when you are searching similar documents, what do you mean? So you identify a few keywords and you search if these keywords exist in other documents also or not, right? So these sort of things, similarly recommendations, RAG and classification. So see, this is, I could say the world is happening or hanging heavily on this topic right now, the Gen AI and agentic AI. Okay, so when I share one practical example on Gen AI, then I'll discuss more on embeddings. But for now, understand this as a form of, I mean, embeddings are nothing but some form wherein machine can understand as a number with a given input text because they don't understand the text. So you translate it to some numbers, then the numbers embeddings can be stored as a vector. This vector go back and check to the base, right? So let me give a simple example. Uh, what is the GDP of India 2026? The moment I put this prompt in ChatGPT, so how ChatGPT works, I'll give a layman example in a minute so you will understand, right? So the moment you enter a prompt like this, what is the GDP of India in 2026? India, for example. So it will transfer, or I would say transform each and every letter of word into embeddings, right? So then they create vectors. In simple language, and text is transforming into some numbers, machine understandable numbers. That is vectors. So these vectors now stored and then used to go and search in the master database, right? There is a massive master database that got trained for these GPTs. So these vectors will go and search. Okay, this is the question. What is the GDP? Then it will go and search the relevant web, pick the number, again translate or transform into a number. Then it will transform to as a text to the user. Same logic, same concept for image creation, any content creation these days per se using GenAI, right? So very powerful, irrespective of your profession, whether you are a lawyer or a doctor or anything, you should have basic understanding of what is this embeddings and vectors and GenAI, because you can actually create on your own. And it will be good for you to, if you're a good prompt engineer, you understand all the basics of data, ML and stuff, you can easily get, I mean, optimize your prompt and get the best value out of it. So I know this is a bit theory, but soon this is my last slide wherein we will jump to the practical problem. Okay, so the last one, this is important, very important. This answers a question, many people ask, like, why doesn't every company build their own GPU? I'm sorry, ChatGPT. Because ChatGPT built by someone, right? Claudia built by someone. Why doesn't every company build its own GPT? The answer is simple, which is cost and GPU. So GPU is again processing unit. So you have to have invest a lot to process massive amount of data. Training large models from scratch is incredibly expensive. So imagine teaching a child everything from birth, just a baby born, all right? You started teaching to the child how much energy you have to put, right? So every language, every book, every scientific concept, right? It's impossible. It requires data, it requires GPUs, and then money. So this is where transfer learning changed the game. Instead of building transfer learning, means instead of building a brain from scratch, you start with an already educated brain. For example, Shakespeare doesn't need to build ChatGPT. It can start with an existing model. Could be any model of ChatGPT. Then say, okay, I'll use this ChatGPT. I'll call the service through API. And if my consumer asking something through prompt, it use the mechanism and search the product catalog descriptions and come back and throw as an output to the consumer. This is faster, right? I'll show you one example, okay? Don't worry. So this is like instead of you building, already they built GPT. The GPT, the moment you put something, it will go and hit the massive data, bring the response and share as a content, right? So this is helpful for product search, customer support, inventory optimization, everywhere. and this is cheaper also. You just have to pay to the tokens. Token is number of queries that you prompted, number of words that you prompted, and you extracted from the master base. Based on the tokens, you have to pay to the GPT or Claude, etc. Right? So PyTorch is one popular. TensorFlow, Keras are two frameworks basically. People use Hugging Face is one another application to store all the AI models. Okay, so this idea of transfer learning is one of the biggest reasons AI adoption exploded over the last 2 years. Okay,